Okay. Uh, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all teachers. Okay, today I'm gonna talk about MTS 1074, which is basic algebra for my assignment, problem solving of linear programming. And firstly, my name is Imran Adham bin Adli from class Maths 2. So for my introduction, I will talk about resources optimization. Linear programming helps allocate limited resources. Example like funding, time, materials efficiently across various projects and initiatives related to SDGs. This optimization ensures that resources are used effectively to achieve multiple goals simultaneously. Next, is multi-objective planning. The SDG involve a wide range of objectives and targets. Linear programming enables decision makers to balance and prioritize this objective by considering trade-offs, ultimately aiding in the planning and implementation of policies and projects that contribute to sustainable development. Next is cost-effective solution. Linear programming helps identify cost-effective strategies for achieving the SDGs. It can be used to minimize costs while maximize the impact of interventions, ensuring that available resources are used to their fullest potential in addressing global challenges such as poverty, health, education, and environment sustainability. Next, I'm going to talk about the problem that we have, which is optimizing clean energy production. So the situation is, you are a manager of a clean energy company that produces both solar panels and wind turbines. Your goal is to maximize the production of this product to meet the increasing demand while staying within your budget. You have two production lines, line A for solar panels and line B for wind turbines. Next, Next is optimizing. Uh, Continue this question. The production of each solar panel in units costs 50 ringgit in material and 10 ringgit in labor, which is each wind turbine costs 40 ringgit in materials and 20 ringgit in labor. You have a budget of 15,000 to spend on materials and 5,000 for labor. Your market research indicates that you can sell each solar panel for 1,000 ringgit and each wind turbine for 800. Next, for the question A, if X is the number of solar panels to produce and Y is the number of wind turbine to produce, write down two inequalities that satisfy the condition apart from X more than 0 and Y more than 0, more than or equal to 0. B. Draw and shade the region R on a graph that satisfies the condition. Based on the graph, if the number of solar panels to produce is 100, find the maximum number of wind turbines to produce. How many solar panels and wind turbine to produce to maximize your profit while staying within budget? Next is step 1. Our first solving step is define the variables. Let X represent the number of solar panels to produce and Y represent the number of wind turbine to produce. Next step is you need to determine the objective. The objective is to maximize the profit. So which can be calculated as the revenue minus the cost. The revenue from X solar panel is 1000X and the revenue from Y wind turbine is 100Y. The cost of producing X solar panel is 50X plus 10X equal to 60X, and the cost of producing Y wind turbine is 40Y plus 20Y equal to 60Y. So the objective function is at maximize Z 1000X plus 800Y minus 60x plus 60y, then we will get z equal to 940x plus 740y. For the next step is we need to determine the constraint, formulate the constraint. For A is budget constraint for the materials. What we will get is 50x plus 40y less than or equal to 15,000. For B, that is budget constraint for labor, 10x plus 20y less than or equal to 5,000. For non-negativity constraint, x more than or equal to 0 and y more than or equal to 0. Next is draw the table. Create a table by substituting any value in the range of the graph to determine the coordinate of the point. Like for the equation, we need to separate for each four categories for equation: value of x, value of y, and coordinate xy. First, for equation 5x plus 4y equal to 1500. So the value for the x is x equal to 0 and x equal to 300. Value of y equal to 375 and y equal to 0. So the coordinate that we will get is 0, 0, 365 and 300, 0. For equation x plus 2y equal to 500, the value of x is x equal to 0 and x equal to 500, and value of y equal to y is equal to 250 and y equal to 0. So the coordinate that we will get is, for the first coordinate, 0, 0, 200, 250 and 500, 0. Next is solving step. For the step 5 is graph the constraint. For the budget constraint for material, we need to divide both sides by 10 to simplify it. So what we will get is 5x plus 4y less than or equal to 1500. So as we can see in this green shade, that was the region for the budget constraint for materials. So the area for this is just include the region that shaded. So for the next step is graph the constant for the labor. For the labor, we need to divide both sides by 10 to simplify it. X plus 2y less than or equal to 500. So what we get is the purple shaded region area. This region is the budget constraint for labor. Next is find the feasible region. The R is a region, is the area where all the constraints intersect. In this case, the shaded region below the line for constraint A and B, and in the first quadrant due to the non-negativity constraint C. So when we have do the constraint for the both lines, so we will need to find the value that intersect each other. So what we get is value region R, which is intersect in each other. For next step is label all the coordinate that intersect. In our graph, we have 3 points that intersect, which is point 0, 250, 468 and 468, and lastly 300, 0. Okay, for the next step is answer the question. If the number of solar panels to produce is 1,100, find the maximum number of wind turbines to produce. So based on the graph, 0, 250, so the maximum number of wind turbine is 250. We just need to draw a dotted line from 1,000 at y-axis to the point that lastly intersect both both area intersect, and from that we need to draw the dotted line from that point straight to the x-axis, and we will get the answer. Okay, guys. For the next question is, how many solar panels and one turbine to produce the maximize your profit budget while staying within budget? So our objective function is z equal to 940x plus 740y. Next is objective function is okay. From that objective function, we need to find maximum profit. We must to substitute x and y in intersection point. So in this, we have 3 points. So we need to put each of these coordinate point on the objective function that we found earlier. So the first one is 940 times with 0 plus 740 times 250 equal to 185,000. Next one is 940 times 168 plus 740 times with 168 equal to 282,240. Next is 940 times with 300 plus 740 times with 0 equal to 282,000. Next is answer the when we get the answer. So among all these answer, the coordinate that we give the maximum point is 100. The answer is R ringgit mentioned 282,240 ringgit. Next, this is for the findings and discussion. So we need to start the uses of resources use. The new programming help figure